Okay, so bigger picture, where it falls into the pipeline. Like I said, you have mostly been working on building out an individual pipeline, right? And that's something to automate the release and deployment of a single application, even if that application has multiple services or components, like a front end, a back end, and a database. Now, Kubernetes is an orchestration tool. So it allows for the deployment and running of multiple pipelines. So really just continuing to scale up since the very start of the curriculum. Does that about make sense or more or less?
Kind of.
Kind of. Okay, cool.
So, like, for example, if we take a workflow that we are using for CI/CD pipeline, we can use Kubernetes to essentially scale that.
Yeah, essentially, yes. So let's say the pipeline allows you to deploy a single app, right? So it's like provisioning uh, a single EC2 resource or multiple if you're defining multiple ones. And it's deploying that app to that EC2 resource. Now, imagine a cluster of these EC2s, except instead of EC2s, they're pods, pods within a cluster. So you could have pods that persist over a long period of time to um, act as an internal host or node for teams to SSH into to use to host an app, to deploy an app to, etc. You could even think of it as a cluster scaling the creation of these nodes at let's say if the use case is for public use, right? So as you get more visitors, as you get more traffic, it will spin up more pods, right? So that's one use case. Now, I'm wondering if I feel like I kind of lost my train of thought there. Before I go on, does that make any more sense?
Yes.
Okay, cool. Yes. We yeah, at Innova, we have a few different use cases for Kubernetes. Basically, we've been migrating all of our applications to Kubernetes. It's a long and slow process, but the idea is, right, being an orchestration tool, Kubernetes is, I wouldn't want to say, I'm struggling to find the right words here. It's not necessarily more powerful. Um, it's like more efficient. There we go. At handling the scaling of multiple instances, right? So as we saw last week, we saw a dashboard that gave us insight into a cluster, into the different components within that cluster. So your different pods and configurations and whatnot, your volumes, your connections. It just has a lot. There's a lot in the toolkit that things like GitHub Actions or Docker really just don't inherently have out of the box, right? I'm sure you could write custom solutions using these other tools to accomplish a lot of the same things, but off the bat, Kubernetes is designed to solve these problems, right? That aren't being solved by these other tools that we've learned so far.
Is this kind of part of the problem with some people not agreeing with the concept of continuous deployment? or continuous delivery.
Uh, how do you mean?
Well, I've heard that like the CI part is, something a lot of I guess companies do well, but then the CD part is kind of I wouldn't say ignored or avoided, but it's just something that they haven't really figured out in some cases. Is it because of, I guess, trying to figure out how to tie in Kubernetes?
Maybe, maybe. Let me think of a good way of answering this. Okay. So at Innova, it's a fintech company, right? There's multiple brands. Each brand is like a different app that has a different target audience. So, um, a loan application for consumers, loan applications for small businesses. One of the small business brands that we own was actually acquired in recent years, and their architecture is very over-engineered. It's highly prone to breaking, and it's their solution is creative, but there's a reason we're adapting this app to our standards at Innova and moving everything over to Kubernetes slowly, like one piece, one service at a time. And that's because, like I said, it was over-engineered before, right? So their integration of continuous deployment is using Ansible to create inventory files of hundreds of services and apps, right? So they would have this naming convention where it's S5 app 1, S5 app 2, up to like S5 app 250 or something like that, right? And every app every number within that is essentially tied to a service. There might be pairs, so basically 1 and 2 will belong to one service, 3 and 4 will belong to another service. So if one goes down, the other one is still available. If they have to create updates, they'll do it at one um, node at a time, right? So the user should not experience any downtime. Now, this is all handled through Ansible. Ansible running a variety of playbooks on various inventories. But what we found over time was while this worked great in theory, it is so prone to human error. There came a point where there are just dozens of inventory files that no one even knows like who owns them or who they belong to. Trying to keep these inventory files up to date had been a nightmare because they'd be edited by different teams and there'd be duplicates or just flat out wrong references, right? Like P5 app 150 being grouped under the wrong group and actually pointing to a different app as a result. So when the playbook runs to maybe disable Nginx or restart the service, it accidentally hits the wrong service or something along those lines, right? So it's been a mess. Now, as we move over to Kubernetes, we have um, the ability to utilize these manifests that can just easily spin up and spin down um, as many instances or as few instances as we want, right? So now we don't have to manually provision or create placeholders, you should say, for one host or two hosts, right? That off the bat simplifies the configuration. We don't have to have these large inventory files anymore. And a lot of the spinning up and spinning down is automated. So we don't have to monitor the pipelines that run the various playbooks that we have to either disable the front end, restart the back end, etc. It's still really hard to conceptualize if you don't, and even if you do see it firsthand, I would say it's still hard to conceptualize and hard to articulate. Like I'm still having a bit of a hard time articulating it, but basically the end result is a more reliable system, a more reliable infrastructure. Now, whether it's easier to use or harder to use, that's subjective, but
Your real world example definitely helped
cool. Cool. We have
because
a
I guess Kubernetes kind of helps with some more automation, and you don't have to necessarily keep track of, let's say, those inventory files in your example.
exactly. Yeah. Um, Now there is still, of course, going to be a lot of configuration on the back end, and for us, that means, well, not just for us. Typically, Kubernetes, you'll write configurations through Helm charts in addition to because these manifests that we've been writing um, during our labs, like they're kind of ephemeral, right? We're not really like grouping them into a bigger context, which I think is kind of unfortunate because it doesn't. I just feel like our Kubernetes section could definitely use a lot of development or growth. We could expand into a lot more of Kubernetes, and we really only explore like the surface of Kubernetes. But you'll the goal is to get you familiar enough to understand in a nutshell how Kubernetes works, right? So while you might not know how to write Helm charts to configure different services within an architecture or an infrastructure, that kind of gives you that bigger picture understanding of Kubernetes at scale. You'll at least learn how to run Kubernetes, um, write configurations, be able to use CLI commands to inspect these various resources and to really just navigate Kubernetes at a broad level.
Think we're getting there.
Cool. Awesome. So last Saturday, I think you all covered secrets and config maps, and we're going to review a bit of that today. Not really review because I think it's pretty straightforward, but we'll start off our lab with that. But before we do, let's just run through our readmes. Today we are going to be covering volumes and storage. So let me close all these other windows to get up our curriculum. We have another use case at Innova as well for Kubernetes where we have a developer experience team that helps it's one of the DevOps teams. This one in particular helps the software engineers. They improve the developer experience. It's kind of in the name, right? So one of the ways they do that is they provide um, a user acceptance testing on demand tool. It's kind of a mouthful, so we just call it UAT on demand. And what that does is it allows software engineers to spin up as many pods or instances of their applications in a cluster itself, right? So they no longer have to spin up this app locally on their local machines. And they can if they want to start out with ads. But once they have enough of the code changed to a point where they want to test, they just spin up a pod. They work in an environment that does not use up their local resources, so it doesn't have to run on the local machine. And it essentially emulates production and it's abstracted away from production so they could do whatever without fear of, like real world consequences. We're not actually going to be breaking the app and upsetting a lot of users, right? So that's another use case for Kubernetes. And it's just a lot easier to use the Yeah, just to use Kubernetes to spin up and spin down these pods, then to like let's say manually run workflow that's going to provision an EC2 that's going to have a different IP each time that you're going to have to SSH into or access through a browser, right? It's just I wish you could see it in action. It'd just be maybe I'll see if I could demo it next week. We'll see. I'll think about it. Uh that's
Magical.
yeah. Okay. So let's share. I'm not seeing the Zoom thing. Oh, there it is. All right, so volumes. We are going to cover three different types of storage inside of Kubernetes, and we're going to see how we could write configurations for each of them. Off the bat, it might be confusing at first. I think I thought it was a little confusing at first too, but really these are just three different methods, right? And there's pros and cons for each method. And which you use will depend on your need and your use case, right? So the first method is to essentially create an empty directory. And an empty directory volume is essentially, it's just like creating a temp folder on your local machine or an EC2, right? It's not designed to, it's not intended to persist, which is why it's separate from persistent volume, which we'll cover last. But the idea is this could be like a middle grounds for simpler workflows, shorter workflows. It's ideal for essentially, yeah, ephemeral processes. Ephemeral because it only exists as long as the pod, right? So we've been talking about clusters and pods. Clusters can spin up like any number of pods. So you could use pods the way that you would in AWS Lambda, for example, right? You only spin it up when you need the task it needs to run to be run. Very similar to a GitHub Actions workspace as well. These are intended to be ephemeral workspaces, not spaces that persist over time. So let's say you have a workflow, an automation that needs to run on a schedule to retrieve, I don't know, a bank file, right? And maybe it has to run every 24 hours at a certain time. It integrates with a third-party vendor, so their setup is outside of your control. They want you to access the file through SFTP. So you write a configuration that spins up a pod that will SFTP into their host, retrieve the file, and then store it inside of this empty directory inside of the pod. And from there, we send the file back to the host. The pod spins down and disappears from existence, and the host has the file that they need. So that's essentially what empty directory is. It's just kind of like a staging ground. It's a temporary place to pass data through. So let's look at this configuration line by line. So just like we've seen before, we're specifying a version and a type. We are creating a pod, and well, let's give it some metadata, right? So we'll call this web server. It's going to run a container that utilizes HTTPD, which is the Apache daemon. And this is our web container. What it's going to do is it's going to have a mount path set to cache, and we are going to give it a name, cache volume. So within the container, we are specifying this mount path, right? So this is the path inside of the container that we are interacting with files. At the pod level, because container runs in the pod, it's a separate configuration, right? At the pod level, we basically use the same name and we use empty directory to basically mount an empty directory to this cache directory inside of the container, right? So you could just imagine if you were to do this manually, you'd be creating a directory, mkdir, mtdir, if you want to call it that, and you're mounting it to cache inside of the container. Inside of a Docker file, um, if you can imagine how we write volume mount inside of a Docker file, we have volume, we have the left path, colon, right path, where the left path represents the location on your local machine or wherever the container is going to run. And the path on the right is inside of the container, right? This is the same thing. We have the host or the origin and the container that runs on that host or origin. So, right, if we were to create this, so let's go ahead, let's copy that. Let's hop into VS Code. Let's use this directory. What are we going to call this? mtdir.yaml. Okay. So let's save that. And now let's run applied on it. Okay, so we now have our observer pod created. Now let's do describe, or actually, let's get our pods. Oh, I should have spun down these other ones. And we see our web server has been up for 15 seconds. Let's do a describe on it. Okay. So we can see, well, we have a container inside of this pod. It is running the HTTPD image, which it grabbed from Docker. And we see a mount called cache. And if we look at the volumes section, we see the type is set to empty dir. And even in the description, it tells us essentially what this type is, right? It's intended to be a temporary directory. So that's how we can configure an empty directory. Um, so we can configure an empty directory volume with medium memory or setting key value medium memory. And we use a temporary file system in the host's memory to store the data within the volume. We already know that once the pod is gone, or if it restarts, or if it's destroyed, then this data is going to be lost. So one benefit, of course, is that this is fast, and if its use case is simple, then temporary storage is probably good enough for whatever you're trying to accomplish. Okay, multi-container pod using empty directory. So let's see what's happening here. Here we're creating a pod that's running two containers, and we're able to use this exact same empty directory inside of both containers. So we set a mount path. I don't know if it's necessary for them to be different. So I don't know why they're different in this example, but if we were to create these and inspect them, we would see their their paths are different. So let's say web servers plural, and then let's go ahead and apply this. Okay, let's rename this to 2 and 3. Giving me that. Oh, okay. So, right, I renamed the containers, not the pod, so I have to rename the pod. Now, if we run a describe on this new pod, we can see there should be a single empty directory and two separate mounts inside of one inside of each container. Simple enough, right? So the other two types of storage are fairly similar, especially even in configuration, especially the next one, host paths. This is the one that you're probably most familiar with, which is why we might have kind of maybe makes more sense to have started with this one. But this is essentially what you do inside of Docker, right? So inside of a Docker file, when you set the volume, that's essentially what you're doing. You're mounting a path on the host machine to the path inside of the container. This is useful for all sorts of stuff because anything that changes inside of the container will be reflected on your local machine or wherever that container is running, and vice versa. If you were to make updates locally, it gets reflected inside of the container. And this is especially handy if, let's say, you're working on a React application, right? Because one of the benefits of React is whenever you update the source directory or a file within the source directory, you can see those updates live in your browser. Now, if you were running your app inside of a container because you have it linked up to other containers like a backend API and a database, you won't be able to make changes as you debug or add features or whatever on your local machine unless you have that source directory mounted from the local machine to the path inside of the container. So host paths is essentially the same. That's essentially what's happening with a host path. You're setting a directory from the host machine to mount into the container. And the way we write it is very similar to how we write the empty directory, right? We, inside of our container configuration, we specify a path. The path, again, is going to be the path inside of the container. We give it a name. we match that name to something inside of a volume, but instead of using the type empty directory, we're going to use host path. So let's go ahead and I guess this one's called host path. Make a new YAML. We're going to make a pod. It's going to be named host path. It's going to run Nginx. It's going to have data as the mount path. And we're going to grab data from the host directory or the host, the data directory from the host. Okay. So let's apply this. Let's inspect it. And if we look at type, we see that it's now set to host path. And we have the data directory inside of the container as the mounted directory. Okay, so again, there are limitations here, just like with empty directory. Less limitations because the data is going to be available on the host. It's also useful for quick non-persistent storage. But if you have a use case that's more dependent on persistent data, that's where persistent volumes and volume claims come into play. And these are cluster managed resources, kind of like how your Docker file and Docker Compose can reference a volume, and that volume is managed by Docker. So if you were to run Docker volume and pass in the necessary arguments, you could inspect and interact with different volumes you've created through Docker. So it's the same thing here. Persistent volumes is just like the name suggests, volumes that persist over time. So because it persists, it's no longer tied to that specific node, right? Here we have our data directory mounted to data inside of this single pod. If we update that data directory inside of the pod, we're not necessarily going to see that if we were to mount our local directory again to another pod. That's where persistent volume comes into play. We could have data that will persist even across multiple nodes. And it's cluster managed storage. So the node, you don't have to worry about the data being lost once you spin the node down or if the node just crashes. Okay, now this does require a little more configuration. The first part is going to be very similar. We essentially add very similar blocks inside of the config, but we're also going to need a separate file as well. So inside of our pod, we would say something like, yeah, let's make this pod first. And we'll just call it pod.yaml just for the sake of familiarity. Let's move that so it's following the other examples. Just like before, we are specifying that we want a pod we have a container inside the pod. This one's going to be using Nginx. We set some default parameters like the container port, and then we mount. Again, we set the directory that we want to mount, right? So in this case, it's going to be data again. Now, instead of using host path under volumes, we're going to use persistent volume claim. Okay. And we're going to reference a claim named my PVC. Now, what does this represent? What does that mean? What is it actually pointing to? Right? Nothing yet. We have to create this persistent volume claim. So let's make a new manifest called PVC dot YAML. Maybe let's call it PV dash PVC, just like the example does, just to make it clear that we're creating two resources here. And right, in this example, we're actually, I guess, creating two separate files, but they can share the same file. So let's go ahead, let's grab this. Let's add a line break and let's copy this here as well. Now inside of this manifest, we have two new resources. They're not pods. One is a persistent volume and one is a persistent volume claim. So we give the volume a name. It's my persistent volume. We could give it labels. We specify settings like the storage capacity, the type of file system for the volume, access modes, and this is where it should look a little familiar. We're setting a directory that should match what we have inside of our actual pod, right? So the mount path inside the pod should match the host path. And then we have to create a persistent volume claim. And this has some additional, no, a lot of the same configs actually, but it looks like we're configuring this to have read write many and we have a selector that will match for this label in the metadata above. Okay, so all of this looks good. And if we go ahead and apply both of these. So first, let's apply our pvpvc.yaml. It looks like these already existed and I never deleted them. So let's see. Let's describe. I was hoping to see something about how long this existed, but I think this might have existed from the last time I ran this. So that's why it said unchanged. That's the only thing that kind of threw me off. So apparently I still have these volumes and the claim that has persisted all these months since the last cohort, maybe even since the one before that. And that's the benefit of persistent volumes, right? You don't have to worry about that data disappearing. Okay, now that we've got that, we can apply our pod.yaml that utilizes this. And so we've created a PVC pod. Let's cube control describe that. Whoops. Gotta specify the type. Okay. So it's got our Nginx container. It's got a mount for the data directory, and it's using a persistent volume claim. And it gives us the claim name, and the claim is what maps to the volume itself. Simple enough, right? Okay. All right. So these have been pretty straightforward. Are there any questions?
So did we combine PV and PVC into one YAML file?
Yes.
Okay.
Yeah. Yeah, I think they're separate in an example just to be a little more explicit about each being a separate resource, right? But it kind of doesn't make sense to make one without the other, unless you already have like maybe a claim that you want to map to multiple volumes. But since we didn't have, I was about to say, since we didn't have these already existing, even though we did, um, it wouldn't make sense to run one without the other. Okay, let's see. Let's do one more example, and let's have everyone follow along. So have your terminal open, create a new directory, um, and follow along, make these same files that I'm making, just so we get some of that muscle memory and repetition down. Okay, so I'm gonna cd up. I'm gonna make a new directory, and let's see. Just like last Saturday, we're going to specify a config map and some secrets. We are going to let's take a look at last Saturday real quick. Last Saturday, we had an assignment where we deployed a MongoDB database. Let's do the same thing, but with Postgres instead. So your assignment was to create a config map, create secrets, create a deployment file, and then expose that database with a service. We're going to do all of this again, but now with the addition of setting some additional volumes. All right, so our config map. What should we call this, by the way? Let's just say PSQL config map YAML. Here, we are going to specify a version, so V1. We're going to specify type. So again, config map, just like last week. And we're going to give it a name. I'm going to actually just call it PSQL config. And let's give it a database. DB. Okay. There's our config map. All right. Who wants to share their screen and write our secrets?
I have a question.
Sure.
When we write kind, is that specifying a built-in service that kind of like Docker knows that Kubernetes already offers and it's pulling from Like the backend is already set up. We just have to write it out properly to actually use config map. Does that make sense?
Yeah, I think I get what you're asking. So when we're running like kube control commands and we're interacting with various resources, um, we could specify the kind, right, to show what's what of that kind exists. And so if we do the same for config map, we can see that we've created these config maps. Um, they exist, right? So as we saw in the previous file, we set kinds for persistent volume and persistent volume claims. And again, we could use those exact same keywords to sort of, but yes, to your point, it is, like I think you, as you said, built in, right? So if we were to have a typo here, it would throw an error when we try to apply because it wouldn't recognize that kind if we were to,
Okay.
yeah, misspell it. So let's see.
I guess I'll share. No one else is speaking.
Awesome. Let me stop sharing. And Jeremy is going to create our secret.yaml.
Why do they open every single one? A config map similar to this.
We did, we should have already had the config map, but now we're going to want the secrets, right?
Something like this.
Mhm.
I don't know how to write it out without copying it. So
You could have it as a reference, but yeah, let's type it out manually just to get that moving. And the first part is going to be API version. And then you have autopilot.
yeah, once Chandra, told us about it, and I'm like, oh, that looks pretty good. But it's not. It gives you like an 80% solution. It's not always perfect.
No, definitely not. Be over reliant on AI, but it's definitely handy. That's why we are going to be adding a buttload of it to our curriculum.
Yeah. What is opaque mean? I didn't ask that last time.
Um,
Is that also referencing a type of service?
the I don't remember what opaque means. Kubernetes secrets. So let me look that up. From Kubernetes point of view, the contents of this secret is unstructured, so it can contain arbitrary key value pairs. Okay, so basically you could set whatever key value pair you want in the secrets. You don't have to like follow some kind of like template or format, right?
Okay.
Okay. All right, so this looks mostly good, except we're going to want to base 64 encode the username and password. So one way we could do that is to go into your terminal and let's run an echo and let's do a -n. So get rid of that double quotes -n. And now you can pass in quotes your username and then do a pipe and then base 64. You could try it. The B, I don't know if the B has to be lowercase. Cool. So there's your base 64 encoded username. So let's copy that into our config. And it looks like your password's already base encoded, maybe.
Oh, I just did a waterfall. No.
Okay.
This might be a stupid question. Will base64, like security sets or whatever this library has, is it always going to give you the exact same? I don't want to call this like a hash, but the output.
Um, Good question. I don't use it enough to say confidently. I would think it would, but we could try that. Um, also makes me wonder. So if we were to run this multiple times, yeah, it's giving me the same value each time. And if I were to run a decode on it, so echo space the value, whoops, and then type the base64 dash dash code, it decodes the value. What does our README say? This just has me thinking if if the point is security, because like let's say maybe this YAML were to be pushed to a repository where it's publicly accessible, there's nothing stopping anyone from decoding.
That's what I was thinking.
Yeah, right. Let's see.
Unless it's like you need some sort of key or cert to get it.
It's a very simple encryption decryption, so it's not going to require any of that. Let's see. I just want to reference last week's. It doesn't say. Okay, so I think that's just a property of Kubernetes. It just has to be base64 encoded. It's not necessarily like a repository security related thing.
Okay.
Okay. So that should be good. Let's save that. We have our config and our secrets. Now I think if we run an apply on both of these, we good to go. Oh, you have to pass in the file name and the file type. Okay. Oh, your V in version.
Not. Oh. Supposed to be a capital too. Huh? Yep.
Mine's, or I'm just working through an error on mine.
Yeah, I'm getting the same errors as Jeremy.
Um,
I just changed, I made this capital, this, and then this, and this.
okay, so I got my secret. We should all be caught up here. Now this is where we can start to expand on last Saturday's lesson. So far we've got a config map, we've got a secret. What's next?
What's next? Need a namespace. Quote.
Did you all write a deployment for, or yeah,
Deployment and a service.
yeah. Can't find one, that's okay. We just read one from scratch. Let's start with the API version again. Yeah, that's good. Apps v1. And let's set the kind. Yep. And yeah, I'll give it some metadata. You can do that with labels.
Does it, you know what version you want to use?
You can just use the latest.
Autofills with Chandra. That's fine.
I think we might be missing ports. Okay, there it is.
Is this really necessary? This probe?
Um, Not right now, no. So once what that probe is, it's similar to how we were writing health checks in Docker Compose, right? You could use that probe to ensure that the database or the container, whatever you're using that in that container, that it's inside a healthy state before moving on to the next container.
Okay.
In this case, you don't need it. We just have one container. And then we just have to make sure we pass in all of the necessary environment variables like the name of the database, name of the user, and the password, which looks like you have all of that in your report. So I think you're good. Okay, so let me catch up. I just have to add my environment variables. I think I might just copy paste them from earlier. And now we could start adding some volume mounts. So okay, inside of your deployment, let's start by adding a new block. Let's not do that yet. Let's not make a new file. Inside of the deployment file, we'll add a new line inside of containers called volume mounts and make sure it lines up with environment and all the other stuff. It doesn't need a dash.
Under a new, yeah, right here. Or
Yeah.
is this an environment variable?
No, it doesn't. I just remove the dash and I think it should be good. Okay. All right. So basically we're setting a volume mounts property for this container. So as long as it is inside, nested under PSQL, we're good. And yep, that path looks good. So that will be our, well, that's going to be the persistent storage. So we could call that, we could call that something like persistent storage, or actually pSQL storage is fine too. But for the example, let's create 3 different types of mounts. Let's make sure we try out each one. So we'll do a temporary empty directory, mounted host path, and a persistent storage. So you don't need to repeat volume mounts. You could just have multiple entries under it. Yeah. Okay, so now let's do a temp storage. Yeah, and that's fine. You could just map it to temp. And
The host path?
yep.
Or no, directory? Is that what it is?
Okay. Now, okay, that looks good. Now we could create a volumes block. And this is basically going to also, it's going to exist under containers. So it just needs to be indented one to the left. Okay. I think that's too much.
I don't think it lets me go.
There we go. That should be.
It doesn't let me do it because it's under. It'd have to be like that. Right.
It shouldn't be. Maybe it
So
is.
if it is it supposed to be under, because all these are under post or pSQL. Postgres.
Yeah, but it should be separated from the container.
Yeah.
So let me just sure. Yeah, I think remove the dash and indent it left. Yeah, left one more. Okay, yeah, that should be good. Okay, all right, now we can create 3 new entries, one for the temp storage, one for the host path, and one for the persistent storage. So just match the names And for persistent storage, we want to use the persistent volume claim. Okay. And I think you need to indent claim name one more time. Okay, cool. Yep. Yeah, let's use the directory type. Okay. And the host path can be anything. Let's make it anything. Sure. I think you
I
might,
like that.
yeah, give it a forward slash. And now let's add another line and let's give it a type. And actually, you need to also hit enter before the forward slash. Indent and give it a key called path colon.
That
And now line up type underneath path. And we'll set it to directory or create.
work.
All one word, but camel case. So capital O. Now, if that directory doesn't exist on the host, it's going to create it. Okay, and that should be good. All right. So now we've got our deployment file. Next, we have to actually create the persistent volume and persistent volume claim. So let's make a new file and let's call it something like pv-pvc.yaml.
A new file.
Yep,
A new volume in here.
a new file.
Oh, a new file. See claim.
Like pv-pvc. So we're making two resources here. We're going to be making persistent volume and a persistent volume claim. Okay, so let's start with how we start with everything else with a version. And yep, we could do persistent volume. Okay. Now we could add a spec block. We'll set the capacity. Yeah, all of that looks good. And we just want to make sure that host path matches. What's inside the deployment file.
Yeah.
Okay, next we want to make the PVC. So let's do the triple dash. And oh, also just noticed for host path, you do need the path colon again.
Well, isn't that what you
Yeah,
just be underneath?
yeah, exactly, just like that. Okay. Now our persistent volume claim. All of that looks good also.
Add path.
This does not need a path. You could think of this claim as kind of like being, you know how in Terraform, if we make policies, we have to attach roles to the policy and users to the roles, etc. It's essentially like that. The claim is like an attachment.
Okay.
So that should be good. Let's save and let's apply it.
Just this one.
Yeah, let's do this one for now. I want to see, make sure it doesn't throw any errors. Cool. All right, so we are now done with the persistent volumes. Uh, Go ahead and run a describe. Like do a kube control get a persistent volume, for example.
We're trying to get.
Persistent volume, get persistent volume. No dash. Cool. Okay. So your persistent volume has been created. It says it's unset right now. So let's go ahead and apply that pod that's referencing it. So let's apply the deployment.
We want to deploy it, or
Yeah. Run the apply on the deployment file. I'll an extra P.
it's supposed to be there. It's not supposed to be that.
I'm not sure why you're getting that. Let's see.
Jeremy, can you scroll down again? Um, Check out that host path on line 43. I think the P has to be capital. That's what I have.
Yep. Thought it'd be good to have case sensitive code.
I think it's called camel case.
Okay, so yeah. Who invented that?
Someone like Julius. I'm kidding.
Ugh.
Okay, are we still getting it?
I got it. I
Okay,
agree. Yeah.
nice. Okay, I think the last step then is to expose the database with a service. Let's see. So let's go and make another file. This one we could just call it service or something, whatever service.yaml. Again, we set the API version. Yep.
We always need to use node port or it's not matter. Actually, I don't know if we're doing an app. Are we doing an app?
Let's see. Yeah, you want to match it to what you named your Postgres app. And you don't need type here. You could, yeah, do type, but shift it to the left one. Yeah, node port, and that should be same line. Next we want to specify the ports. Yep. Except we're probably going to want to change those values.
Same 5432 or
Yeah, that's good. Set the port and the target port to that 5432. The node port, I think those have to be different.
this one we add like a 0 to it, right? Or
yeah, you do that. Also just do what um Copilot is saying, 3000, whatever. And then we want to shift the ports or the port part of ports. Okay. I think ports needs to be lined up with selector. Okay. Cool. And maybe shift the dash. Everything from line 11 through 14, left one more. Okay. All right, let's save and let's apply it.
Mine worked, but I did change my app to P-SQL. Oh, the node port. I also have a capital P. Yep.
Cool. Can you get the service as well?
Yep.
Let's do a kube control get service. Cool. And let's do a Minikube dashboard.
What's this?
Okay. Why is it failing? Can you click on, inside of deployment, click on MySQL deployment? Let's scroll down. Let's look at some of the logs. Available false. What's that message say? Scroll up a bit. Okay. Can we go to your terminal and can you type kube control get PVC? Okay, it's found. None. Okay, so I'm seeing a different error, I think. I also have multiple ones running, so I probably should have destroyed the other ones. Um, so what I'm seeing is it looks like it's bound, but the volume attributes is unset. Let's try. try a cube control describe PVC and whatever you named your PVC. Oh, and you need to change the V in cube control. So describe, you need to pass in the PVC keyword first.
The Jeremy PV.
PVC and then Jeremy PV. Okay. What's everyone else seeing? Does anyone have a healthy PostgreSQL pod?
I have the same thing as Jeremy.
Okay. Yeah, I do too. Sure is. And try. I'm gonna run through. Okay, I see it. I think I see it. Inside of our PV, there's a storage class name that we did not add. Okay, so let's go back to the pv-pvc.yaml. Um, within spec, at the same level as capacity and access modes, let's add a volume mode. Let's set it to file system. And let's also add a storage class name. And we could just call this something like standard. All right, let's save. Let's delete this current PV and let's recreate it. So Q control delete PV and whatever the name of the PV is. And then reapply. And what's your dashboard showing now? Thing.
Do I need to delete the deployment and redo it?
So it wouldn't hurt. Who ran through the assignment on Saturday with for the MongoDB version?
We all did.
What's that?
I think we all did.
Did you um use Kubernetes dashboard at the end to inspect the MongoDB?
I did not. Goodness, really.
Okay. Okay. I am going to continue to troubleshoot this because I think we're getting similar issues anyway. I'm going to open up breakout rooms so we could start on the assignments. Uh, today's assignments are pretty similar to the lab. You're going to be creating PVs and PVCs for Engine X, and then continuing the Golden Waste assignment from Saturday, adding some volumes to that. Here is the assignment URL. And I'll open up breakout rooms and I'll be here to continue troubleshooting this. And we could break for now.
Sounds good.